Hey everyone, this is Berwin, the lead tutor from Berleaf Education. It has been a while and I'm very happy to be back with more episodes of Just Ask Berleaf, where we explore more of the common exam questions and see how we can tackle them with ease. Now, if you have any questions, please feel free to drop me a message via the contact found in the description right below. And most importantly, subscribe to my YouTube channel for more of my videos. Now let's get started with our questions for today. We will be working on two common questions related to factors and multiple. There are some prerequisite knowledge that you will require, so do check out these videos prior to getting started. So let's get started with question 1, which you can see it right at the bottom of the screen. Alright, 504k is a perfect cube integer. Given that k is also an integer, find the smallest possible value of k. There are 4 important pieces of information that we can identify from this question. And the very first would be that 504k is a multiple. And it's a product of 504 and k. Second, this multiple that we are looking at is actually a perfect cube. Thirdly, 504k and k are both integers. As such, they must be whole numbers, not fraction, not decimal, right? And lastly, it will be that we are looking for the smallest possible value of k. Alright, now do take a moment, pause the video if you are trying to digest this important information that I've just mentioned, and start the video again once you're ready. Alright, let's get started to solve the question. Now, when I'm dealing with such a question, the very first thing that I would definitely want to do is to express the multiple as the product of its prime factors. So the multiple that we are referring to is 504k. Now, since k is already a factor that we can see in this multiple, so we will first leave aside k and focus on breaking down 504 using the prime factorization method, which is also known as the ladder method. So now let's get into it. We will have a ladder, and this is at the top, 504. We are dividing it with a smallest possible prime number, that would be 2 as of moment, and giving us 252. This can be divided by 2 again, giving us 1, 2, 6. And then 2 again, which gives us 63. This would be divisible by 3, giving us 21. And with 21, we'll divide by 3 again, giving us 7. And last but not least is to divide it by 7, giving us a 1. Alright, now 504k is actually the product of 504 and k. Right? So let's express the 504 as its prime factors. So we have 2 cubed times 3 square times 7. Right? So not to forget, times k. Alright, so that makes up 504k. Now with the above, we are able to proceed to step 2, where we solve for the value of k by satisfying the requirements of a perfect cube, which is a number that can be cube rooted without leaving any remainder. And it has a very important characteristic, which is for any perfect cube, the exponents of all of its prime factors must be a multiple of 3. So an exponent is also referring to the power that normally floats on the top right of a number. Now for easier reference, let me write this down one more time. 504k equals to 2 cubed times 3 squared times 7 times k. And from here we can see that the prime factor of 2 has an exponent of 3, and prime factor of 3 has an exponent of 2, and lastly 7 has an exponent of 1. Do take note that it isn't 0. Now from here, we are able to observe which of the prime factors did not satisfy the above requirement of a perfect cube. And that's obviously what we can see here. 3 and 7, they do not have exponents that are multiple of 3. This is exactly where k will come in to top up the exponents to a multiple of 3 for both the prime factors of 3 and 7. Now we do so by multiplying into 2 cubed times 3 squared times 7, an additional 3 as well as a 7 squared. Now through a simple comparison, you can see that this portion represents k. So we therefore can say that the value of k is equals to 3 times 7 squared, giving us 147. Alright, that wraps it up for the first question. Let's proceed on to the second question. Alright, in question 2, the HCF and LCM of 120 and k are 12 and 4680 respectively. Find the value of k where it is an integer. Now, even though this question does look quite different from question 1, however, the steps that I've shared with you in question 1 are actually pretty generic, where you can actually apply to most of the questions that are related to factors and multiples as well as prime factorization. So likewise, let's apply it to question 2 and see how we can use it to solve the question. So similarly, we start off with expressing the given numbers as the product of their prime factors. Right, we are referring to the numbers 120, 12, and 4680 since k is just an algebra. We're gonna start breaking it down with a ladder method with 120 first. So 2, that gives us 60, and another 2 gives us 30. Then we have another 2, give us 15. This can be 3, that was 5, and lastly 5, giving us 1. Alright, so we proceed to the next number, which is 12. Okay, so this is simple. It's going to be divided by 2, which gives us 6. Another 2, gives us 3. Then lastly 3, giving us 1. Okay. So moving forward to look at the next number, that would be 4680. Now it's an even number. As such, we can divide it with 2, giving us 2340. Another 2, which gives us 1170. Okay, and divide by 2 again, that's giving us 585. Alright, for this can be divided by 3. So we have 195. Okay. Another 3, and that would give us 65. Okay, this would be divisible by 5, giving us 13. And last but not least is 13, giving us 1. Next, we shall express each of them as a product of their own prime factors. So for 120, we have it as 2 cubed times 3 times 5, while 12 would be 2 squared times 3. And last but not least, 4680 is 2 cubed times 3 squared times 5 times 13. So what we have done here is pretty much the same as step 1 that we have done in question 1, which is to express the numbers in the product of its prime factors. The main purpose of this is to enable us to observe the relationship or the requirements that we will need to satisfy in order to solve for the unknown that we are looking for, which is exactly what we're going to do in step number 2. where we will start off with determining the relationships between the numbers and k, and thereby solving for k via a logical deduction. Alright, so let's look at all pieces of information and see how they connect with one another. Now we will start off by listing out the obvious, which is that the HCF of this entire question that we are looking at is actually 12, right? Which is represented by 2 square times 3. While the LCM would be that of 4680, which is represented by 2 cubed times 3 square times 5 times 13. To help you better visualize how does the HCF and LCM connects with one another, we shall make use of the ladder method working. Alright, let's draw it out. So on the very first row, we have 120, which is represented by 2 cubed times 3 times 5. Alright, and also not to forget k. Okay, let's fill in the rest of the information into this ladder method. So we start off with HCF, which we know that is the product of all the common factors here, found on the left, whereby we start off with a 2, and then it go all the way down, so we can fill in on the left column. It's a 2 as well on the second row, and then 3, then that's the end, right? What we have at the end, let's call it A and B over here. So do remember that the left hand side column, if you multiply the factors all together, you will actually get the HCF, right? Which is 12. So at the same time, we can observe that we are able to work out the value of A, which is 120 divided by 12. Let me highlight this in green because the 12 represents the HCF, right? So 120 divided by the HCF would give us 10. So that's the value of A. And when expressed as the product of its prime factors, we get 2 times 5. So in the same fashion, but working in a backwards manner, we are able to use B to find what's the value of K, whereby K is actually equivalent to B times 12, which is the HCF. So from here, we are able to see that in order to find the value of K, we will have to find the value of B first, right? So that is where let's consider the concept of LCM. Now LCM is represented by, let me highlight for you, in the ladder, it will be from here all the way to where A and B is. So it is actually a multiplication of the HCF with A and B. Let's write it out. LCM is equals to HCF times A times B. And writing it out as their prime factors, we have 2 square times 3, highlight in green because it's HCF, and then times A, which is 2 times 5, while B is what we are trying to find, right? Now next, let's compile whatever that we have here, which is 2 cubed, and that is 3, and then times 5 times B. We can figure out the value of B by making a comparison of what we have so far with the prime factorized LCM that we have done earlier on. We will want to do so for every term, be it the 2, the 3, right, the 5, or even the 13, okay? Now let me do this in more of a visual manner by eliminating whatever that is already of existence in the LCM below from the prime factorized LCM seen above. So we already have one of the 2 cubed. We have a 3, but okay, so we are missing a 3. And then we have a 5 already. And that's about it, right? So practically what we are missing is actually that of a 3 and a 13. So this is where B will come in to top up for these missing factors. As such, we can say that the value of B is actually equivalent to 3 times 13, which is 39. So once we have found the value of b and remembering this, right, which is k is equals to b times 12, we are able to work out our value of k, which is 39 times 12, which gives us 468. Alright, that's all for today. I'll be exploring more of these questions in the coming days. Please do subscribe to my channel. And if you have any questions, please feel free to just ask Berleaf. See you on the next episode. Ciao.